Okay, so this should be on either Thursday or Friday of the 18th or 19th, I think. And I will hopefully be back in class on the 22nd, next Monday. Again, I'm actually filming this on, 2nd of March, right? So filming this like 2.5 weeks early. This is the last one too, so video I hope I have to make for all my time that I'm out. 2 weeks from now, they might have a better idea when we'll be back in school, right? Right now, it's only the 2nd of March. We just heard yesterday on the 1st of March when Gavin Newsom said that he wants everyone back in school by the end of the month. So we'll see what happens, okay? Anyways, you'll be seeing this video on the 18th, 19th, so this is 2nd, so it's about 16 days from now. So we're going to be going through the last set. When we're done with this, make sure that you submitted all 3 of the assignments for the week. And like I said, we're kind of taking a break here at the beginning of, or the end of the 3rd quarter, beginning of the 4th quarter, doing this review here for 2 reasons. One is just to kind of take a little break from curriculum to just start focusing on school next year and college and all that, and placement tests, and just kind of refreshing your memory and stuff that you might need to know for that. And then also, it just makes it a little easier on everybody, myself and you, since I'm not there to answer questions or anything like that. So I didn't want to cover any curriculum while I was out with recovering from my surgery. But I also didn't want to do nothing, right? If we can't do nothing for a week. So I thought it might be good to finish this up. And again, you probably have noticed that I originally planned on, remember, I was trying to figure out how to best utilize Wednesdays, right? Because you got that little half-hour period of time. And so last semester I did it by testing on Wednesdays, right? And I didn't think that worked so great. Kind of stressful trying to do it all in that half-hour time period. A lot of people submitting late and all that stuff, right? So then I thought, well, let's try to do college placement stuff on Wednesdays. But then it came up that a lot of times on Wednesdays we actually ended up needing that for stuff we had done on Monday and Tuesday, just finishing up, right? Or other things. So anyways, we've been kind of getting behind. Remember, I wanted to do a second placement test, right? We did the first one at the beginning of the semester, and I said, oh, we want to work on one intermittently throughout the year. But it turns out then I had the surgery thing, and it turns out that this is one way to get this second one done, and then we can go back to our regular programming, right? Calc kids, we're going to start on Monday with the chain rule 2.5, and that's a really important section. At least to some other kind of cool ideas. It relates to, it eventually goes to something called related rates, and that was when I really first got into calculus and realized, oh, this is actually cool. Because at the beginning there's just like limits and learning how to take derivatives, and you're not really doing anything with it yet. You're just learning how to take derivatives, right? But then also for the advanced topics class, we're going to go back to where we actually started the 3rd unit on trig, which is on circle trigonometry, and we'll be going back to that when I get back, hopefully on the 22nd. And then again, the jury's out as to, again, remember, this is only the 2nd of March when I'm filming this. The jury's out as to whether or not we will be remote learning or will be hybrid learning and stuff like that. So it's all going to be a new world for us, right? As they all come out of our caves that we've been in for the last year. And hopefully it's the beginning of a better tomorrow for everybody. Okay, before we start, let's put ourselves in the presence of the Lord. In the name of the Father, Son, and Holy Spirit, amen. In the name of the Father, Son, Holy Spirit, amen. Okay, so the first question is kind of similar to the one we had before, but it's a little more challenging. This question is like the other circle question we had, but it wasn't so easy. Like the other one ended up being, it looked complicated, but it was actually ended up being just 1/2 base times height. But this one here, a little more complicated. So you got a circle And then you have another circle. Sorry, my circles are not nearly as good as Mr. Brown's. And then you have this. And these are both the centers of each circles. And these are both. Now, one thing that's going to tell us, okay, let's make sure we hit. There's a radius of 8, okay? So remember, if this is the center, and that's the center, that's the center, and that's the center, but that's also the edge, and that was also the, so let me give the color. Let me give this circles colors that might help explain what I'm trying to say here. So we'll call the top circle the red circle, and the bottom circle. Now, there's something that you may have picked up on. Notice I haven't even read the question yet. I'm just thinking about it, right? Like I'm looking at the picture, looking at what's going on. I think that's one of the things that makes a person good at math. Is just that the way they go about addressing the question. I didn't read through just to find the question, man. So I'm thinking about what's there, right? So I got this black equilateral triangle here, and what I know about this is. If this is the center, and it goes out, so center of the blue one goes here, that has to be 8. And if this is the center, it goes out to the blue one, that has to be 8. And if this is the center of the red one, it goes out here, that has to be 8. So notice that triangle isn't just any old triangle, it's an equilateral triangle. Now this is where it gets a little dicey. If you know the formula of an equilateral triangle's area, this question's easy. But not many people do. It's one of those formulas that not everyone learns in geometry. And I'll be honest, when I had geometry, I didn't learn this formula. You know when I learned it is when I went to Africa, because it was actually part of the curriculum in the European, in the English system. Because the system I taught in Africa I taught in a country was called Swaziland at the time. It's now called Eswatini. They changed their name a few years ago, and they were a British protectorate until I think 1968. So they still have what's called the O levels. They still teach under the Cambridge and Oxford high school system that they do in Britain. And in Britain, they do teach the area formula. So what we want is the area here. And this is 8, and that's 8, and that's 8, right? There's a formula for this. There's a formula. In America, we don't usually teach this formula. The formula for the area of an equilateral triangle, if you don't know, is √3/4 times the side squared. And so if you know the formula, this would be the reason I kind of have fond memories of this type of question, because it's the type of question that they would have on their high school, what they would probably be the equivalent of the AP exam. But they would actually test all 4 years, not just the calculus part. And then the side is 8 squared, so I get √3/4 times 64. 4 goes into 64 16 times. So you end up with 16√3. Now, you might be thinking, well, this figures, you just told us that in America we don't normally learn this formula, right? Yeah, in America you're going to have to actually to figure it out on your own, which is kind of a pain. What do you do here? We go back to the old-fashioned area is 1/2 base times height, right? It's not super duper hard, but it's a little painful to do it the other way. Because, well, we know the base is 8, that's not a problem. It's the height. Like, how do I figure out what the height of that is? It's not 8, right? It's got to be less than 8, right? Because it's tipping and being 8. How do you figure out the height? Well, what you have to do is you have to actually deconstruct this and pull out the right triangle out of either half. You can do either one, doesn't matter. Because if that's 8 and that's 4, you have to remember way back in geometry we learned 30, and then remember, the other thing too is you need to know what an equilateral triangle is. Each angle is 60, isn't it? right? 60 plus 60 plus 60, because it's equilateral. They're all the same angle, so they're all 60. So it's 60 plus 60 plus 60, right? So this is going to be 60, that's going to be 60, and that's going to be 60, right? So that means that's 60, so that makes that 30. So this is a 30, 60, 90 triangle, right? And we know that the formula for a 30, 60, 90 triangle is 1, 2, root 3. And you have to remember that from geometry to answer this question, don't you? So, so that if that's 4, then that's 8, and this is going to be 4 root 3. Half times 4 is 8, times 4 is 16, so you still get the right answer. But boy, wouldn't it be nice if we learned this formula in the United States? Well, I don't know if it's all that nice, right? Because how often in your life are you going to use that one formula, right? Not in this test, right? So it's probably no big deal. But anyways, that's 33 is a lot trickier than 28, right? If you, I'll just look back at the assignment. 28 was a very similar question, but you actually had the height and you had the base, so it was easy. Here, what's the problem? We don't know the height of this thing. Unless, you've done a lot of math in your life, right? So again, don't panic on this one if you're like, Mr. Pierce, I'm not going to remember that one. Skip it, move on to the next one. As we talked about before, you're not going to know every one of these questions, right? You just want to get as many of them as you can. You're not expected to get them all. That's why the range goes so wide, okay? That's why the range is so wide in the questions. Some questions, you're going to go, Mr. Pierce, why is it that way? Because that's not the way we normally take tests, right? We normally don't do it quite that way. But that's how you do diagnostic or placement tests, right? So 34. 34. This is a straight algebra question. So you got y squared plus y over 3xy times 3x plus 3 over y squared plus 2y plus 1. What you want to do in these type of questions, you want to try to factor the heck out of it and factor as much as you can out, and you kind of hope that stuff cancels. We had a couple questions like this on the first one. If you remember the first packet that we did, in the first packet, there were 2 questions. In one case, almost everything factored in canceled, and you got a 1. And in the other case, almost nothing factored. I think this one's kind of in the middle. Some will factor, but not everything. And this is more normal. So notice on the top one here, you can factor a y out. Let's switch to blue. So notice in the top fraction here, you can factor a y out. It's all called factoring out a common factor. And then 3xy. Here, you probably want to factor the 3 out. And here, let's see, y, 2 numbers that multiply to 1. Well, that's got to be 1 and 1, doesn't it? Yeah, and the middle term will be 2. So there it is. There's everything that factors. Oh, I forgot the y here, though. Oops. Oops, daisy. So then what you want to do is you want to start, canceling stuff out. Now, again, this is hit or miss, right? Sometimes you might get a situation where nothing cancels. And then other times, a whole bunch of stuff will cancel, and you just don't know until you do it, right? So let's see what we got here. One of these will cancel, doesn't matter which. And the 3 will cancel. Ooh, and the y cancels. So what am I left with when everything cancels out here? And remember, they're really 1s, aren't they? And that normally doesn't play out unless everything cancels. And then sometimes people write 0s instead of a 1. Remember, when you divide, y divided by y, you end up with 1 over 1, really, right? So the only thing that's left is the x plus 1. And then you have the x. This is x. And then you have 1 of the y plus 1s. Now those don't cancel because they have to be exactly the same, right? And so there's the answer to that one. Hold on, I forgot to write the letter for just for clarity. This was D as in dog for number 16. Oh no, geez, why did I say 6? Oh, because I saw the 16 there. That's weird. 33. And then 34 is E as an elephant. And again, this is a question you do in Algebra 1 and Algebra 2. And some people are better at it than others in terms of factoring stuff out. Okay, I'm going to slide down, so we're going to lose question 33 here. 5, 4, 3, 2, 1. So let me slide down, but I'll leave 34 in the picture. It's got that triangle we don't really need anymore. Let's see if I move on a little bit farther. There, how about that? And then, so 30, 35. Now, this is another question that you're either going to remember the formula or you're not. This is a quadratic equation and it doesn't factor. Okay. 2x squared minus 2x minus 1 equals 0. Now, typically what you try to do, you try to factor it. But sadly, it won't. No matter how many times you try to do it, you're going to do 2x and x. And no matter how you do this, you're going to have an even number this way and an odd number this way, so it'll never make an even number. Now, I do math my whole life, so I see that. It's not going to freaking factor, right? But having said that, it might not occur to someone that it doesn't factor right away. You might have a little bit of trial and error here. Here's my kind of rule of thumb I do, or when I used to teach Algebra 1 and Algebra 2, which I have not done since like the early 90s. I think I told you the only year I taught algebra geometry was like 94. I think the only year I taught Algebra 1 was like 92. I think the only year I taught Algebra 2 was like 96. So it's been like 20 years since I taught those 3 classes. But my rule of thumb when I would teach these classes for factoring, try to factor it for about 30 seconds. And if it doesn't come to you, then use the quadratic formula. Now, if after 30 seconds you're like, oh, I think I'm close, then spend another 30 seconds. But if you're like after a minute, you're like, I'm still 30 seconds or a minute, I'm lost, then use the quadratic formula. Now, you need to remember the formula though, right? Minus b plus or minus the square root of b squared minus 4ac to a. And that's either a formula you're going to remember on the day of the test or you're not. Like I said before, usually these are no calculator, no notes, right? You just go in, you take it cold, right? So you're either going to remember the formula for this or you're not going to remember the formula for that. Now it is multiple choice. And you'll notice that one of the reasons that you might want to think that it doesn't factor, possibly, is notice that some of your choices here are these plus or minus stuff. So that's kind of a hint that you might need the quadratic equation. Now there's a couple choices where there's not, so you can't be guaranteed you're going to need the quadratic equation on this thing, right? So, anyways, if we have the equation here. This is under the assumption that ax squared plus bx squared plus c equals 0, right? That's the assumption. So what we're going to say in this particular case then is a is 2, b is negative 2, and notice it's imperative that you pay attention to those negative signs so you can get all foobarred when you do it, right? And c is negative 1. It's really important you don't miss those negative signs, right? So the opposite of b, if b is negative 2, then the opposite of b would be 2. Negative 2 squared is 4. A is 2 and b and c is negative 1 over a is 2, so 2 times 2 is 4. So now here's the deal. I've got to make that look like one of my answers, right? So we got to keep working at it, right? We got a negative and a negative is positive, so 2 plus or minus 4 plus 8 over 4. Oh, that's a crappy 4 though, isn't it? I'm running out of room here, so I'm not gonna do anything. I'm just gonna rewrite it. I'm going from here up to here. Since I'm going from the bottom up to the top, I'm not going to touch it yet. I'm not going to do anything. I think we know that 4 plus 8 is 12. Now, if it were me, I'd be okay with that answer. Okay? But it doesn't match any of our choices, does it? So you have to realize the square root of 12. Remember the square root of 12, when we do that over here, is the square root of 4 times the square root of 3, isn't it? I can break this is just a side note, right? So I can make it 2 root 3. So notice what I can do here. 2 plus or minus 2 root 3. So I can factor the 2 out. Now I know some of you do this differently, that's fine. So then I can cancel the 2. I know some of you would do it this way, which is perfectly. Some of you would skip this step and you cancel the 2's here. That's perfectly fine. You get the same answer. Oh, I forgot the plus or minus. So 1 plus or minus root 3 over 2, which is B as in boy. So the answer to this one is B as in boy. Again, just be aware that there are going to be questions on the test that make assumptions that you know certain things. And one of the things that they want you to know is the quadratic formula. So again, that might be one of those things that I would, if I was you, that might be on like my small list of things that I would memorize before I walk into the test, if I'm taking a placement test, okay? So let's slide down. We're gonna lose 34 here. And now we're on, see, that took up a lot of space there. Let's see if I can fit that there. Could probably move this over just a little bit like that. I don't know if that's going to be that helpful, but that generates a little more space for me here. Again, I'm trying to keep the previous question in when I do the next one, and that's not going to always be possible, but whenever possible, we want to try doing it. Logarithm question. How good are you good at logs? And the thing about logs, and we've talked about this before, I think, kind of one of those things that, the one thing about logarithms is you don't do them that often. And when you're doing them, you remember all the rules and you get good at it. But then when you're not doing them, it's one of those things that out of sight, out of mind, and you just forget the log rules. So what do we get here? Log 3x squared minus log 3x equals 2. How am I going to do this question? Well, you got to remember your log rules, right? So we have certain rules that we have, right? And let me write them down. Okay. There are 3 rules that you have to know for logs. Log A plus log B is the log of A, B. So if you're adding, you can put them together. Oh, you can't quite see that. I'm going to move 35 off the screen right now. So I'm going to count down here in case anyone's still writing down the quadratic one. 5, 4, 3, 2, 1. I want to make sure I can fit this on here, so let's slide this down. Okay. So log rule. Log A plus log B is log AB. Another log rule, and this is the one we're going to need for this particular question, log A minus log B is log A divided by B. And the third log rule, log A, let's use, I don't want to use both A's. Let's call this X and this A. You can bring that up as a power. Now, again, you have to remember those rules, right? Now, the real log thing is this. This is the big one, right? So this is one set of log rules. manipulating the logs. And we're going to need, I think, this one for this question. And then there's the big one that we learn. This is the important one, I think, in the grand scheme of things, is that logarithms are actually the inverse of exponentials. Remember, an exponential is y equals b to the x. So how do you get the inverse? You switch the x and the y. So these are actually equal. They're saying the same exact thing, aren't they? Right? So we're going to need, I think, these two rules to make this go. So now, just something that I kind of skipped here. This is assuming the bases are the same. If the bases aren't the same, you can't do this work, right? On this one here, it kind of doesn't matter because it's the same base automatically, right? So it's imperative these were both threes. If they weren't both threes, then you couldn't do the question, right? So now the rule's minus, so I can put it together as division. So what I'm going to do is say that's log base 3 of x squared divided by x equals 2, because that's what the log rule says, right? Log of a minus log of b, so I can do x squared divided by x. But the thing is, we know x squared divided by x is just x. And then we have, so notice I use this log rule, so I put a little asterisk by it. And then now I'm going to use this log rule. The base is 3, y is 2, has to equal x. Just rewriting this, the b is 3, the x, and the y is 2. So we can see that x is going to be 9. So x is going to be 9, and that's D as in dog. D as in dog. Okay, now I'm going to have to start moving the board to see the next one, so we're going to lose this one immediately here. So let me just stop here for a second. Let's count down 5, 4, 3, 2, 1. Okay, I'm going to slide this one out of the way. Again, it's a video, so you can pause it, right? You're not done. Pause. Okay, number 37. What is the product of... This is what we call complex numbers. Now, complex numbers are numbers that are what we call two-dimensional numbers. They're not on a number line. They're in what's called the complex plane, right? What we know is, and this comes from this idea here. This all comes from this one idea. X squared equals -1. What is the square root of -1? Well, until we talk about complex numbers, we say that it doesn't exist. We say that there is no solution, right? You can't take the square root of a negative. And that's true if you are limiting yourself to the real number line. So if we only had real numbers, and here's like the real number line, right? So we got the positive, like 1, 2, 3, 4, 1, -1, -2, -4, right? 1, 2, 3, 4, -1, -2. So we just have a regular number line, right? But what we're going to do is we're going to create another number line going perpendicular to that number line, right? Going this way. Instead of calling it 1, 2, 3, we're going to call it I, 2i, 3i. -I, -2i, -3i. And that generates what are called complex numbers. Complex numbers have a real part and an imaginary part. Sometimes the parts can be 0, which is, we're going to talk about that. But so like here, 1, 2i would be right there, wouldn't it? The middle part is 1, and then The other one would be at 3i would be right there, right? And then the question is, what happens if you multiply these two numbers together, right? That's the question, right? What happens if you multiply the two numbers together? And again, what we're going to do is we're going to call this I. I. So whenever you get, that's I. So here's the, and you might confuse, all of this stuff, I don't need to do this question. You know you don't, but there's a conclusion here you kind of need. And that is, well, if that's true, then x squared is I squared. If I square it back again, oh, and that's what we need, you guys. If none of this makes sense to you, don't worry about it. What do you actually need to do this question? You have to remember I squared is -1. Now, don't get me wrong. I mean, if you're going to go on in math, this has to make sense to you because you have to realize that numbers are not one-dimensional, right? They're multi-dimensional. All right, right? Just like, you know, I mean, we try to pretend that we live in a linear world, but who's to say that it really is, right? It just makes life simpler for us if we, you know, don't have the idea of living in multiple dimensions. But if you start talking about string theory and stuff like that, you're talking about lots of dimensions and stuff, right? And the world is probably a lot more complicated than we imagine it to be. But we like to view numbers as linear, right? Like real numbers is just number line. We don't like to really think about numbers that much in other dimensions, but some people do like to think about stuff like that, physicists and mathematicians and stuff, right? So about, you know, space holding and time travel and wormholes and all that kind of crap, right? So anyway, so we can imagine a different world than just this number line if we want, right? But here's the conclusion, guys. If that all is like, because I really don't care about it, I squared equals -1 is really the upshot of this, right? So you just treat it like algebra except for that one fact. So the question is actually almost trivial, but the problem is if you just know this one fact, you're kind of missing the beauty of the mathematics in a sense, right? I mean, if you find mathematics beautiful. So anyway, so what happens here then is when you FOIL this out, first times first, outside times outside, inside times inside, and here's the important one, last times last, 2i squared. You have to be able to change that 2i squared to -2. You have to know this. That it turns out to be the only thing you really have to know here. So you get 3 minus 2, which is 1. Then you add the real parts, then you add the imaginary parts. So the answer there is 1 plus 7i. What would that be? If you multiply these two green ones together, 4, 5, 6, 7i would be up here. It'd be up here, wouldn't it? It'd end up there if you multiply these two. It's kind of weird, right? If you multiply these two green dots together, you get that blue dot. That's what we just did, right? Yeah, multiplication in 2 dimensions gives kind of weird looking answers too. So that's weird, actually, now that I think about it. That strikes me as a little odd. Ah, it's right. It's 1 plus 7. The answer is 1 plus 7i. That's the correct answer. And it's B. Let me just make sure I graphed the other 2 points correctly. 1, 2i, right, and then 3i. That's right, yeah. Huh. Who knew? Huh. Yeah, I'm just thinking about the question too much. Everything's fine. I'm dwelling on the question, unfortunately. Okay, so that's 37, and again, I'm going to be sliding the board here in a minute. So let's count down here. 5, 4, 3, 2, 1, and 38. Number 38. This question here, this type of question that some people get, it makes sense to them, and others are like, no, I don't understand, I don't get it. That's okay. I'm gonna try to explain it best I can. This is a function Okay. And here's the deal. Again, remember function boxes, how they work. The function box, when I put x in, I get x squared plus 3. That's what comes out, right? The question here is, what if I put something else in, right? What if I put a 1 in instead? Well, I'd have to do 1 squared plus 3, which would be 4. What if I put 10 in instead? Well, then wherever the x is, I'd put a 10, wouldn't I? And you get 103, right? Well, what if I put in, now here's the question is, what if I don't put x in? What if I put x plus 2 in? What if I put x plus 2 in? Well, that means instead of x, I'm going to have x plus 2. It's important you remember the parenthesis, right? Right? So instead of x, I'm going to have x plus 2 squared plus 3. So again, when you put x in, you get x squared plus 3. That's what they tell you. So if I put 1 in, I get 1 squared plus 3. If I put 10 in, I get... Now, if you put a binomial in, you have to make sure you put a parenthesis, make sure you square both terms, right? Now, remember how this works, though. Don't make that x squared plus 4, right? We talked about that like in an earlier episode, right? You want to say this is x plus 2 times x plus 2. First times first is x squared. Outside times outside, inside times inside, last times last. Don't forget the 3. So you have x squared plus 4x plus 7. Now, notice that you do get the x squared and you do get the 4. I'm not going to argue that. But remember, you're going to miss out on the middle terms if you just bring the power in. Remember, that's one of those rules that sometimes kids forget. They think that you can bring the power in. You can't. You can't. It's against the rules. So you end up with x squared plus 4x plus 7, which is A as in apple. Okay. 39. I'm going to be so close to finishing on this board, but we're not going to make it quite. I'm going to have to move over to do the last question on the other board. Okay. We have a right triangle ABC. Right triangle ABC, and the length of AB, BC, and BE are 20, 15, and 6 respectively. What are the lengths of DE? This is a question that usually has multiple ways to find an answer. I'm going to probably just pick one. I think I said this before that, there's a lot of times there's multiple ways to do it, and I would advise using mine. This is one of the situations where this is probably not so much, that there might be another way that works better than mine that I'm not seeing. Because sometimes there's a lot of ways to do this. So let's see what we got here. We got this big triangle, and then we got this little one here, right? And so what do we have for numbers on this thing? Letters. Let's do letters first. A, B, C, D, E. So we have A here, B here, C here. And it's a right triangle. And this is a right triangle. And then we have the little triangle is going to have a D here and an E here. So we've got, there's our picture. Now they give us a bunch of information that's not on the picture that we have to put on the picture, right? AB is 20. So this distance here is 20. And BC is 15. It's 15. And BE is 6. Oh, that's weird. This little piece here is 6. That's going to be, now we need to now what I'm going to do here is, we're looking for DE. Let me We want this sucker right here, right? So what's important here is what we have to do is we know that okay, I'm now switching to green, and when I switch to green, that's stuff that I'm putting in here in addition. So, no, I mean, we actually knew that was 15. The key here is that this has to be 9. This has to be 9, right? So what I'm going to do for the sake of discussion, I'm going to call this big triangle ABC the blue triangle, and the little triangle I'm going to call the red triangle. So ABC I'm going to refer to as the blue triangle, and I know that this distance is 20 and that distance is 15. And then the red triangle, I know this distance is 9 because that was 6, right? Because it's got to add up to 15. That 9 there is like the big deal on this question, right? Now the thing we're looking for is right here. We can put X there. Now, what we want to use here is what's called similar triangles. X divided by 9 would be the tangent of that question, right? X divided by 9 would be the tangent of that question. This angle is the same as I go all the way out to the blue, isn't it? So that means that the 20 divided by 15 would also be the tangent, right? Let me say that again. If I'm looking at this angle here, right here, angle C. Now I'm thinking it in terms of trigonometry, but you can think of it as similar triangles in geometry. Matter of fact, I think I started off saying it was similar triangles. And I'll do that in a second. Opposite over, so the tangent of that angle is opposite over adjacent. The tangent of that angle is opposite over adjacent. So they're the same, so it's got to be equal. You could also use similar triangles. You could say that this side divided by this side has to equal this side divided by that side. Again, the thing that's a little annoying about this question is they didn't give you the 9 outright, did they? They didn't give us the 9 outright. They gave us the 6. And we had to interpret that makes that red distance here on this side 9. But now we have this here. Now, how you solve that, totally up to you. But I'm going to give you a piece of advice. I would reduce that fraction. That blue fraction, that's going to reduce to 4/3, right? And then the numbers won't be so freaking ginormous, right? So what you want to do here is you probably want to rewrite the question here as x over 9 equals 4 over 3.